Hi everyone, welcome back to Hubble TV. The vast universe contains so many mysteries that people always want to explore and discover. Among the countless mysteries of the universe is something that scientists are investigating, observing, and measuring its energy sources. This is an object that looks like a star, but it is not a star. This object emits an enormous energy source that equals to billions of times that of our Sun. It is defined by scientists as a quasar. So what is a quasar? How big of energy does it have? All of those questions will be explained in today's video. I wish you all have a fun time watching this video, and don't forget to subscribe, turn on the bell to support us. And now, let's explore. Number 1. What is a quasar? Quasars are celestial bodies that look like ordinary stars. However, these are extremely far and extremely bright objects. Compared to ordinary stars, the light emitted from quasars is from a halo of dense material located around the nucleus of active galaxies. Except for powerful and short-term explosions like superobsis or gamma-ray burst, quasars are the brightest objects in the universe. They exist because of a supermassive black hole, with a mass of 1 billion times the mass of the Sun. The quasar's position is at the center of the super galaxy. As we all know, the black hole itself cannot emit radio waves or light. Visible light from quasars comes from a gas disk, and the stellar satellites are called accretion disks by scientists, which encase the black hole. The great heat and light emitted from this accretion disk are caused by friction from the swirling of matter around and slowly falling into the black hole. The normal quasar is usually 100 times brighter than the galaxy that contains it. The quasar also emits a stream of matter from its center, possibly even expanding larger than the host galaxy. When a material flow emitted by quasars interacts with gas around the galaxy, radio waves will be emitted. This is called the radio lobe and can be observed with radio telescopes from the Earth. The supermassive black hole is in the center of the gas and star accretion disk. In the surrounding, the friction is super strong, causing light and forming streams of emitted matter at tremendous velocity. Although the quasar is very bright, if you want to see it, you must use a telescope, since the nearest quasars are also billions of light years away from us. They look quite faint in the night due to light noise. 2. Energy comes from quasars. Quasars generate the energy of millions, billions, or even trillions of electron volts. This energy exceeds the total light of all stars in a galaxy. These are the brightest objects in the universe. They shine anywhere, 10 to 100,000 times brighter than the Milky Way. To make it easy for you to imagine, let's consider the example of an ancient quasar 3C273 that is 2.5 billion light years away from us. If we bring this ancient quasar close to the Earth, 30 light years away from the Earth, or about 285 trillion kilometers, the 3C273 quasar in the sky will still be as bright as our Sun. To remind you, our Sun is only 8 light minutes away from the Earth, while we are thinking of bringing the quasar closer at 30 light years away from us. So you can imagine how much energy quasars emit. According to NASA, quasars are capable of emitting hundreds or even thousands of times all the energy emitted by our galaxy, making them one of the most luminous and energetic objects in the entire universe. The quasar's overall luminous intensity ranges from 10 to the power of 40 to 10 to the power of 41 watts. 1,000 to 10,000 times the total luminous intensity from all the stars of any supermassive galaxy. Meanwhile, quasar radiation is emitted from only a small region, 1/10 millionth of the galactic size because it is only radiated around the accretion disk surrounding a super black hole. The cause of the quasar's enormous energy production is explained by many theories, stemming from many different physical mechanisms and processes, in which scientists gave three main hypotheses. Hypothesis 1. The collision or the explosion of very massive stars or galaxies in clusters. Hypothesis 2. The accretion on black holes is derived from the collapse of a star, supermassive stars, galaxies, or intergalactic matter. Hypothesis 3. Plasma object from rotating motion. Both the rotating motion hypothesis or the first hypothesis have difficulty in explaining the cause of the quasar's luminous energy and gas dispersion. This is explained by the fact that the mass of the quasar nucleus is about 100 million the mass of our Sun. Hypothesis 3 states that, theoretically, rotational motion can emit a large amount of energy in a relatively small volume, and the emitted radiation is displacement cyclical. The total energy emitted will be proportional to the mass of the quasar, and the average energy ranges from 10 to the power of 45 to 10 to the power of 46 J per unit mass, equivalent to the Sun. Scientists stopped at hypothesis, but the formation of quasars is still a big mystery that takes time for scientists to discover. Please leave your comments below to share your thoughts with everyone about this fact. 3. Observation history of quasars. For many people, quasars are something completely new and heard for the first time, but scientists have discovered and observed them for a long time. The first quasar was discovered in 1963 and given the symbol 3C273. This quasar was discovered by a Dutch-American astronomer who discovered the constellation Seven Women from Palomar Observatory. Up to now, scientists have discovered hundreds of thousands of quasars in the universe. In the 50s of the 20th century, radio telescopes were greatly improved. The idea of finding an extraterrestrial civilization was supported and funded by the US government at an early stage through the SETI, which means the Search for an Extraterrestrial Civilization. The staff of the SETI program was determined to search for the radio signals of the bodies intentionally emitted by extraterrestrial civilizations from space. Of course, as the radio telescopes targeted the most powerful sources of radio transmissions, astronomers are directed their optical telescopes to these locations on the radio maps of the stars to do light analysis of these sources. Previously, the existence of collisions between two galaxies that caused an outburst of high-energy thermonuclear reactions along with subsequent radio radiation was confirmed. However, the radio sources in the sky resemble a normal translucent star with a weak apparent magnitude. The biggest question here is why there exists such intense radio radiation without the collisions of two galaxies. From the high-resolution images at the time, the quasars seemed like some kind of light source. Therefore, they are considered radio stars in the galaxy. However, some astronomers believe in their out-of-galactic origins. The assembling of optical and radio spectrum components is very complex. The first bundled radio source bearing the 3C48 symbol, according to the third Cambridge list of radio sources, answered many questions. These spectral assemblies contain longitudinal spectral lines that cannot be identified as unknown element spectral lines. Ultimately, they must call them special stars that emit radio radiation. In 1963, the Balmer sequence of the spectral lines of the hydrogen element was discovered in the spectrum of the quasar 3C273 in an unusual position that no one had found at the time. The cause of this unusual spectral line position is the redshift phenomenon, where this value of the 3C275 quasar is z equals to 0.158. Scientists believe that this redshift is too large to appear due to the impact of the gravitational field. After pondering over the possibilities, scientists declared that the last acceptable cause was the expansion of the universe. Based on the recognition of the expanding universe theory, and according to the Hubble theorem, if considering the cosmological model, the distance of the quasar 3C273 is about 2 billion light-years. The absolute star class is -26.2 m, and the luminous energy corresponding to the energies of tens of trillions of 10 to the power of 13 suns, which is 50 times brighter than the brightest known galaxy. To get that redshift, the 3C273 quasar had to travel away at 47,000 kilometers per second, while the only greater speed known to astronomers was the speed of light. If you have learned something new today, please like, subscribe to the channel, and share it with your friends. And here are some other videos you will like. Please click to watch more.